Alright.
How do we graph this? Now, I agree that we could plug it in our calculator and look at a table of values, but there's a way faster way that we already know, isn't there? Can't we just use transformations? How did this move from the parent? To the right 2 and up 3, right? So from the origin, if I move to the right 2 and up 3, that is my vertex, right? Now, is there a multiplier in the front? No, so I know its parent function shape. So from the vertex, remember we talked about going over 1 up 1, over 2 up 4, and over 3 up 9. And why could I go over 1 up 1, over 2 up 4, and over 3 up 9? What's 1 squared? 1. What's 2 squared? 4. What's 3 squared? 9, right? It's parent function shape. There's no multiplier in the front to change the shape of my parabola. Okay? And I know parabolas are symmetric, so I know I can just put those points on the other side. You remember talking about this?
Yes, ma'am.
Yes. Okay? So from this point, we would just draw it and go from there, right? No big deal. Again, that's something we've already done, right? That's not anything new and earth-shattering. Okay, what would change if I told you the problem actually looked like this? Would I graph it the same way? I put the points the same way, right? And then what? I have to decide two things. First of all, I have to decide if the line is close, dotted or solid, right? Is this line dotted or solid? This is a dotted line, right? What would make it a solid line? If it was less than or equal to, right? If it had that line underneath it, we know it's a solid line. So I'm going to draw a dotted line. Okay? And then what else do I have to do? I have to shade, right? Now, with a line, when we did linear inequalities, if it was less than, I shaded below. If it was greater than, I shaded above. Does it work that way here? Let's figure out where to shade. How should we figure out where to shade if I don't just have some easy way to remember it? What if we chose a point? Why did I darken this point right here? Because it's the easiest one, right? We almost always want to choose that point. When's the only time we can't choose that point? When my parabola goes through that, right? If my parabola happened to go here, that's fine, right? As long as the parabola doesn't go through that point, we're okay. So 0 is less than 0 minus 2 plus 3. What is 0 minus 2? Negative 2 squared? 4 plus 3. So 0 is less than 7. No, it's not. 0 is, wait, is 0 less than 7? It is? Or it's not? You're telling me all these things by shaking your head at me, so I'm just replying to what you're saying, trying to make you think about it, right? Is 0 less than 7? Wait, yeah, that's what you guys are giving me right now. So I want you to make a decision. Is 0 less than 7?
Yes.
Yes. Where do we shade then? We shade where that point is. Where is that point in relation to the parabola? Now, when we had a line, we had two terms that we talked about, above and below, right? Two kind of opposite terms, above and below. What kind of terms are we going to talk about with a parabola? Two opposite terms. There's one. There's the other one. What's it called? What do you think? Yeah, how about outside and inside? Would that be okay?
Yes.
So is this point inside or outside of the parabola? Outside. So we're going to shade like that. And then we're done. That's your first example. You okay with that? So okay with it. Okay, good. Let's do one more example then. Okay? Here's your problem. All right, how is this different?
There's two.
There's two. What does that mean? It's called?
System.
A system, right? This is a system of inequalities. What does that mean as far as how we do this problem?
You're going to have two.
We're going to have two equations graphed on the same plane, right? And we're only going to shade where they both work, right? We're only going to shade where they both work, okay? Okay, so where is that going to be?
It's going to be on the first.
Well, how about if we start graphing them and figure that out, right? That's what we got to do, okay? Now, if we need to use a calculator, I suppose you can, but we're smarter than that, right? If we're thinking about this first equation right here, we know that it is parent function shaped and
It's up three.
up 3. Up 3. So there's my vertex. I know it's a positive x squared term, so I know it opens up. So over 1, up 1, over 2, up 1, 2, 3, 4, and over 3, up 1, 2, 3, 4, 5, 6, 7, 8, 9. And it's symmetric, so I can draw the other side points in. Is this solid or dotted?
Dotted.
It is dotted. Where would I shade if I was going to shade? If I chose 0, 0, 0 is less than 3.
On the outside.
So on the outside, right? We know that that's true. Now I'm not actually going to shade. I'm just going to tell myself where to shade, right? And then how would I graph this other one?
It would be up and down
Parent function shape that opens down
and up 8.
and up 8. 1, 2, 3, 4, 5, 6, 7, 8. But it's opening down. Why is it opening down?
Negative.
Because of the negative, okay? So over 1, down 1, over 2, down 1, 2, 3, 4, over 3, 5, 6, 7, 8, 9. Ooh, this one I could go 4 and how many? What's 4 squared? 16, right? 10, 11, 12, 13, 14, 15, 16. So I'm not just guessing the shape, I know it. I don't know what bell that is. I don't think it was supposed to ring. I think it was a fake bell. Okay. Yeah, it was a fake bell. Okay. Solid or dotted?
Solid.
Solid. Inside or outside? If I chose this, 0 is greater than 8. Is 0 greater than 8? Is 0 greater than 8? No. Okay, so it goes on the outside. So where do I actually end up shading?
On the side.
So like over here, up to here, right? And then over here, like that. God bless you. Like that? Yeah. You okay with that? Any questions?
Teachers, please disregard that bell. Thank you.